We live in an era where vaccine development is more successful and productive than any other period in history. However, there's still a huge need for research into new vaccines. Like many other areas of modern medicine, the immune system holds the key to unlocking vaccination potential. In UCD, Conor Crawford is working to develop vaccines against infections that are more dangerous to those with weakened immune systems.
There's a few different types of people that can be immunocompromised. Some of these people are people that are going to go under solid organ transplant, those on heavy chemotherapy, or those that are infected with HIV/AIDS.
Tell me about the research that you're working on. You're working on a particular vaccine for a specific type of disease.
Yeah, so the microorganism that we're interested in is Cryptococcus neoformans. And it's a fungi that exists all over the environment. It might even be in this interview right now watching. What this fungi does is it commonly infects people in childhood, but people don't notice, so it's asymptomatic. But then when people become immunocompromised in the future for the various reasons that I stated earlier, that this fungi is a big problem.
That's actually quite scary what you're saying. I could potentially have it right now, but I wouldn't necessarily know until I had a low immune system if I was getting a transplant or if I were a HIV patient, etc.
Yeah, exactly.
Infection was most prevalent during the HIV/AIDS epidemic in the late 80s and 90s. And it continues to be a health concern, particularly in the developing world.
Sub-Saharan Africa is the main place where this fungi is pathogenic. And I would say like 85% of the infections happen in Sub-Saharan Africa. It's around 200,000 people a year are infected. Of them, 180,000 die of the infection.
And if you are immunocompromised, are there already therapies that you could take against this fungi?
There's currently 2 drugs. They work, but often the therapy can take up to 6 months or longer. And there's rising resistance against these anti-fungal medications because of their chronic use and misuse. So that's why we're interested in making a vaccine against this specific fungus.
Conor's research focuses on the fact that cells in our body are surrounded by unique sugar coatings, almost like barcodes, that help the body identify cells and what they do. Harmful fungi also have these coatings, and the aim of Conor's vaccine research is to create replicas of the fungal coating that might help train the immune system to recognise the danger and fight the infection.
So we're kind of like chemical engineers. We make like a library of structures. We've had some interesting hits to date, and that was based off a library of only 10 structures. But now recently we've made a library of 25. So they're not very big numbers, and it's because it's very laborious to make these structures.
And how long, ordinarily, would it take to make one of these structures?
Just one molecule, maybe 4 months.
Wow.
Using a special printing device in the lab, Conor is able to create versions of sugar molecules that are chemically the same as the ones that cover the harmful fungi.
So what the robot uses to print is these little needles here. They're called PDCs, and this sucks up each sugar molecule into it and then sprays it onto the slide, and uses sound energy to do that. So then here we can see the glass slide. You can see that there's lots of green dots of different intensity and different shape. And each of these kind of areas corresponds to a different structure.
Conor is working with researchers in Johns Hopkins University in the United States, where the glass slides are sent to be tested with antibodies, which may identify one of the structures as a potential vaccine candidate.
When you screen it with the antibodies, they all won't be lit up right now the way they are. You'll only see one little area will be bright, and that'll be for one specific sugar. That's interesting to see if it's a vaccine candidate.
And could you see this with your eye? I mean, can you see what's on the glass slides?
Yeah, of course. You can see this, the different sugar spots. And this is what they'll use in America to scan with antibodies.
So potentially a vaccine
is lying on this little piece of glass right now.
That's really important.
Yeah, don't drop it.
The final phase of this vaccine development will be to test promising vaccine candidates in mice to see if they're able to clear the fungal infection. In much the same way as the overuse of antibiotics has led to the antibacterial resistance crisis, antifungal resistance is a growing global threat.
So considering the fact that there may be more fungal viruses going around, we should be really hopeful that there's more research teams like your own working on vaccines.
Yes, research into these different fungal pathogens is very important. If any new problems emerge, that we have tools to fight these new infectious agents.